Okay, so when you're looking at the domain and you're just looking at restrictions, so without sketching, because say you can't sketch something. For example, let's look at this one. So when you're looking at this, if something has a square root, then what's under the square root must be positive. Also, if it is on the denominator, which this one is, it can't equal 0. Okay, so basically this would be x would have to be greater for the domain. X would have to be greater than 0. It can't equal 0 and it can't be negative. So that means it would be 0 to infinity. So let's just say we have the square root of x minus 4. So when we're looking at that, the restriction on the domain there would be what's underneath the square root. That must be positive or equal to 0. So you can go x minus 4 is greater than or equal to 0, x is greater than or equal to 4, or you could go this interval, because it equals 4, up to infinity. So there's a couple of things that restrict the domain. Like if you have, let's just say we don't know how to sketch this, but we do know that x minus 2, x plus 2 can never equal 0. X cannot equal 2 and x cannot equal minus 2. Because if x equals either of these values, like if it was 2, you would put a 0 on the bottom. And as soon as you put a 0 on the bottom, it is undefined. Okay. The same as if you put in minus 2, you get minus 2 minus 2 minus 2 plus 2. So you get 1 over minus 4 times 0, which is undefined. So therefore, when you write the domain for this one, the domain then would be basically all real x except x equals minus 2 and 2. And in interval notation, it's extremely painful because it's minus infinity up to minus 2. Then minus 2, actually it'd be minus 2 to 2. And then we go from 2 to infinity. So as a rule, if you have a function y equals f of x, then basically if you have y equals root f of x, the restriction on the domain would be that whatever's underneath the square root would have to be greater than or equal to 0. So what's under the square root will be greater than or equal to 0. For example, x plus 3, then x plus 3 is greater or equal to 0, x is greater or equal to minus 3. If you have y equals 1 over f of x, then the domain will basically be all real x except f of x equals 0. So basically f of x cannot equal 0, or the denominator cannot equal 0. And that's how you can actually restrict that domain. If you combine those two like this, that means that the domain, the f of x not only has to be not equal to 0, it also has to be positive. So it's what's under the square root is greater than 0, but not equal to 0. And that's how you can form the restriction on your domain.